You ever just look up at the night sky and wonder if we're making all of this way more complicated than it needs to be? Well, today we're diving into an absolutely fascinating story. It's one person's journey, over years, to try and figure out the cosmos, not with a giant telescope, but with a whole lot of curiosity and an internet connection. And it all kicks off with this one simple but really powerful question. What if the huge mysteries, like dark energy and dark matter, aren't that mysterious after all? This whole idea didn't start in some fancy lab. It started as a personal thought, just jotted down in a notebook. And man, does it challenge some big ideas.
So flash forward to November 2011. This initial spark of an idea starts to take real shape. The main goal? To figure out why the universe isn't just expanding, but why it's speeding up. But instead of dreaming up some new, invisible energy, the author looked at something we see every day. Or, well, we don't see it, but it's everywhere. Space itself.
Okay, so here's the core idea, and it's a big one. We all get gravity, right? It's the force that pulls things together, makes things dense. But what if there was an equal and opposite force pushing everything apart? The proposal here is that this isn't some strange, dark energy. Nope. It's just space, doing what space does naturally, expanding. And this leads to a pretty wild conclusion. Maybe space is the fifth fundamental force of nature. It's not just a passive, empty void. It's an active participant in the cosmic dance, a kind of anti-gravity that's always pushing outward. Now, where you have a lot of matter, like in a galaxy, gravity wins. But out in those huge, empty voids between galaxies, that's where this outward push of space is the king. And that's what's driving the expansion of the universe.
So, how do you even wrap your head around an idea this big? Well, the author didn't start with crazy complex equations. Instead, they used some really simple, really powerful analogies to help build a whole new picture of the cosmos in your mind.
In this balloon analogy, it's perfect. It's the key. The universe, in this view, is basically a zero-sum game. Every action has an equal and opposite reaction. So every time gravity creates a dent in space-time, that space has to go somewhere, creating a bulge somewhere else. We've all seen this image before, right? It's the classic bowling ball on a trampoline. A big, massive object like a star creates a gravity well, a dip in space-time, and other smaller things just kind of roll into it. It's how we visualize attraction. Simple enough.
But here's the flip side of that coin. For every one of those gravity wells created by a galaxy, all that displaced space has to pop up somewhere else. It bulges up in the emptiest parts of the universe, creating what the author calls a gravity mound. And these mounds are literally hills in space-time that actively push galaxies away from each other.
I just love this analogy. It gives you such a perfect mental picture of this cosmic game of whack-a-mole, doesn't it? Gravity pushes down here, and space pops right back up over there. It suggests this really dynamic, balanced, and deeply interconnected system running the whole show. And, this isn't just some neat little thought experiment. It could have some serious explanatory power. The author realized these gravity mounds could actually be a single, elegant solution to a bunch of different cosmic puzzles. That extra curvature of space could explain why stars on the edges of galaxies spin way too fast, the very thing we invented dark matter to explain. It might even explain things like gravitational lensing and how the whole cosmic web got its structure in the first place. All right, so if space and gravity are locked in this constant push and pull dance, what's playing the music? What's the engine driving it all? Well, to answer that, the theory has to go from the unbelievably big all the way down to the impossibly small. The hypothesis pulls an idea straight from string theory. It suggests that the energy for all this cosmic expansion is leaking out from tiny, hidden extra dimensions. Think of it like a backstage to our universe, a reservoir of energy that's constantly seeping into our normal three-dimensional space and powering the whole thing. And this is where it gets really weird. These extra dimensions might also solve one of the biggest head-scratchers in quantum mechanics, entanglement. How can two particles talk to each other instantly, even if they're on opposite sides of the universe? Well, maybe it's because they're not traveling through our space at all. They're taking a shortcut, outside of it. Just take a second to think about what that means. To us, the communication looks instant. But in that tiny extra dimension, time might not even work the same way. The author came to believe that every pair of entangled particles is basically connected by its own private, stable, microscopic wormhole. It's a mind-bending idea. Okay, so we've got this grand, all-encompassing theory. It's pretty cool. But an idea, no matter how cool, is just an idea until you can find some proof. And this is what launched the author on a quest that would last for years, digging through scientific data and trying to get the attention of the scientific community.
And you can see from this timeline, this was a serious effort. This wasn't just a fleeting thought. It was a persistent, dedicated investigation, studying weird anomalies, posting ideas on science blogs, even trying to learn the math needed to turn these visual ideas into real equations.
One of the very first things that caught their eye was something called the Pioneer Anomaly. As the Pioneer spacecraft flew out of our solar system, scientists noticed it was slowing down, just a tiny, tiny bit, but consistently and for no reason they could figure out. So the question was, could this be the spacecraft feeling the faint pushback from the gravity mound created by our sun's gravity well?
And the search didn't stop with Pioneer. No, the author went on a deep dive into some of the biggest data sets in all of cosmology. They were hunting for any little clue, any piece of data that didn't quite fit the standard model, but might just line up with this new gravity mound idea, from galaxy rotations to the afterglow of the Big Bang itself.
And that brings us to the last part of this journey. And honestly, maybe the most important part. Because this story isn't really about being right or wrong. It's about that deeply human need to look at the universe and just ask, what if?
This quote, from a post on the Discover magazine blog, I think it says it all. There's no ego here, no claim of having all the answers. It's just a really honest admission of what they did and didn't know, and an open invitation for help. It's a genuine attempt to contribute just one little idea to the great scientific conversation.
When you get right down to it, this whole story is just a powerful reminder that the urge to understand the universe isn't just for people with PhDs and access to supercomputers. It's baked into all of us. It's that drive to find patterns, to tell stories, and to try and make sense of this incredible place we live in.
And so this entire journey leaves us with one last, really important question to think about. In a time where pretty much all of human knowledge is at our fingertips, who gets to ask the big questions? And who gets to try and answer them? It really makes you wonder where the next great breakthrough might come from. And that is a question worth thinking about.